Welcome to BioMotion's executive overview of clinical motion capture. Kinematics is the official word for the study of motion. For us, it starts with cameras, reflective markers, and a couple computers. We do acknowledge that there are other methods of using either active marker systems, magnetic systems, or even a few companies which are producing markerless motion capture systems. For us at this point in time, we believe that the passive marker system is the most accurate and easiest method of creating clinical motion capture. We start off with our subject and a new costume of reflective markers placed on anatomical landmarks, defining the body segments, orientations, and positions, and another set of markers on the same segments on easy-to-view sections which have little to no skin movement if possible. This provides us the method of doing what's called 6 degrees of freedom, of looking at all the motions of each of those limbs with little error as possible. Again, we start off with markers on the body, and here on the right side are two images, the two-dimensional pictures from the motion capture cameras of only the reflections of those markers and nothing else in the room. Whenever two or more cameras are able to see the same marker in space, we are able to calculate a three-dimensional position of those markers. Here's a representation from the mocap 3D view of 5 cameras and the intersecting rays from each of those cameras to a specific marker. This is happening for each of the markers on the person's body, but this being a short representation of the 2D views being put together using trigonometric algorithms to create a three-dimensional position. Here's a side view of the same exact model, which is truly 3D, and the multiple cameras creating that three-dimensional position. Using motion capture, we can track upper extremity, lower extremity gait, or whole body, in this case, in walking. From the three-dimensional positions, 3D models of a person's body can be created. In this case, the orientations denoted by the little axes of yellow, red, and green of each of the limb segments just depicted by geometric shapes of cylinders and cones. But other animation skins can be placed on just as easily. In most cases, for clinical analysis, skeletons are used, but other cartoon characters such as Jar Jar Binks or any other iRobot or other types of movie characters can be placed over those skins. But more importantly for us is the use of motion capture as a virtual goniometer, where for every 60th to 100th of a second, the position of each one of those limb segments in the 3 planes of motion is measured within 1 or 2 degrees of accuracy. In this case, the purple on the left denotes what would be a virtual goniometer, and on the right is the graph for every 60th of a second of a person walking down our walkway, and comparing the motion, which is in red, blue, and green, above the cyan or light blue normal database of the normal population. With multiple markers throughout the entire body, we are able to create a 3D graphical representation of the person's walking, from the pelvis down to the hip, the knee, and the ankle, from the 3 planes of motion. Side view on the left, frontal view on the center, and top-down view on the right. This concludes our short review of motion or kinematics, which describes what a person's limbs are doing accurately and precisely. In the next 2 videos, we will show you how kinetics, or the study of forces, and EMG, the study of the electrical activity of muscles, will help show why a body is moving the way it is, and more importantly, how clinicians can use this information to develop tailored treatment plans for the bones, joints, and muscles that are causing that dysfunction. Thank you.